Hi! So today we're going to be doing another interactive concept presentation. This one involving balloons, and it's not so much of a science experiment as just kind of a general explanation of some electron domain geometry as well as molecular geometry and kind of what that means, honestly. Because there's a couple things that go into these models. Electron domain kind of refers to where it's exactly how it sounds. It's where the electrons are sitting. The molecular geometry is how the atoms, so say you have a CO2, you're going to have, carbon in the middle and oxygen on the sides. It's that shape that it's going to make based on polarity, lone pairs, and charge. So we're going to run through a couple of examples here. And just kind of briefly touch on all of the different kinds that we might be seeing. So the first kind is the molecule is an AB2. So it's going to be a trigonal planar, which basically means, and you'll have to forgive me, not all of these stuck together. So you're going to have it like this. So planar meaning, it's one plane, trigonal, 3 points. For a molecule with this, what we're going to see is one lone pair, and the placement of the lone pair. So the placement kind of determines the geometry, because wherever the lone pair is, it generally tends to move away from that. So for this one, say you have the two here, my hands are here, central is here. The lone is going to be up here, and it's going to come down this way, making the molecular geometry bent. So the next one we have is tetrahedral. So this one is a little bit trickier to show, so you'll have to forgive me. So it's not perfect, but there it is. Yep. So tetrahedral is the next one, and we're going to see again one lone pair. So you're going to have central and then them kind of branching out, and then the lone pairs above that, making the molecular geometry a trigonal pyramidal. So if it helps, you can kind of picture it as coming down like a pyramid. And that molecule is an AB3 molecule. The next one is an AB2. And it is again tetrahedral, but this one is going to have two lone pairs. So the initial shape of the electron domain geometry is going to be the same, and actually it's basically the same as our first example with the bent geometry. So again, you're having the central and then the two here, but now you're going to have a lone pair here and a lone pair here. So you're still pushing the molecules down that way. So next up, we have an AB4 molecule, and that one is going to be called a trigonal bipyramidal. So again, these are getting a little trickier to show. So essentially what it is, it's kind of like that. You're going to have 5. So you have the 4 here, kind of 2 pointing out this way, 1 up and down, and then 1 pointing out to the side. Okay, so that one is going to have one lone pair. So when you look at it, you're going to have these here, this coming off this way. Lone pairs are going to be on the side here. The molecular geometry is going to be called a seesaw shaped. It's helpful that a lot of these are very self-explanatory. So the next one, again, is going to be a trigonal bipyramidal. This one is for an AB3 molecule with 2 lone pairs. So this one, same thing. You're going to have it going up and down like that. You're going to have it branching out to the side and down, but this time you're going to have a lone pair here and a lone pair kind of on the diagonal. And this one is going to form a T-shaped molecule. So there is that one. So we have one more trigonal bipyramidal, Another AB2. This one is going to have 3 lone pairs. So what happens when we have this is we have 2 lone pairs here and then 1 lone pair here. So obviously we have lone pairs kind of changing the charges on the side. So what happens is we just get a linear structure. So essentially, just straight up and down like that. So that one is pretty easy. They kind of balance themselves out because of where the lone pairs are. So the next one we have is an AB5 molecule, and it is going to be called octahedral. Again, quite challenging to show this one. I don't think I have enough actually to show you. So basically what you're going to have is you're going to have 2 going up like this, 2 here, 2 here, and that is going to be your octahedral. So as far as lone pairs go, you have 1 lone pair and it's going to be at the bottom. So you're going to have the central, 2 branch, 1 up, and then the lone pair at the bottom. And as far as molecular geometry, we're going to have a square pyramidal shape. So essentially the shape that we got from where the lone pair is. Last but not least, we have an AB4 electron domain molecule. So this one again is going to be octahedral, 2 lone pairs for this one. And again, we're going to have 1 lone pair here, 1 lone pair here, kind of right on top and bottom of the central atom, which is going to create something called a square planar. So kind of how we talked about earlier, planar, same plane, just like that. All on the same plane. So those are the electron domain geometries. As you can see, they directly relate to the molecular geometry, but when looking at molecular geometry, it's important to look at the lone pairs because that will kind of determine what we're looking at overall. So I hope you enjoyed that little presentation with some balloons for visualization, and thanks for listening.